You know, when you think about building software, it's so incredibly tempting to just think of it like building a
Oh,
house.
yeah, the classic architecture analogy.
Right. You lay down a solid concrete foundation, you put up the load-bearing walls, run the electrical wiring, and then, right at the very end, you hand the keys over to the new homeowner.
Usually with a little manual or something.
Exactly. You hand them a nice little decorating manual so they can figure out like how to arrange their own couches and hang their own pictures. But for today's deep dive, we're looking at a developer who decided to take a radically different approach.
Radically different is putting it lightly.
Yeah, I mean, imagine building that exact same house, but instead of giving the owner a decorating manual, you just pour the furniture directly into the concrete foundation.
Just like cast in stone.
Yes, the couch, the dining table, the bed, they're bolted down. They are immovable, a permanent part of the structure.
Okay, let's unpack this because today, our resident learner, we are looking at a developer who committed what many traditionalists would consider a massive programming cardinal sin.
They really did.
They deliberately fused the presentation layer directly into the core code, all just to guarantee an absolutely uncorruptible user experience.
It's a profound shift, really, in how we usually think about software design. We're looking at a very specific, highly technical, and honestly surprisingly philosophical blog post from May 1st, 2026.
And this was written by a developer named Ang, right?
Yeah, Eng. And it's titled Notes on Haskell Programming, Part 124, Integrating Custom Tips Templates with Pandoc.
Catchy title.
Right, it's very technical. And on the surface, we're going to be dissecting Haskell language extensions and compiler mechanics. But the underlying theme here, I mean, it's universal to anyone who builds things for other people.
Which is pretty much all of us in some way. Exactly. It's the relentless, sometimes messy pursuit
Yeah.
of creating something that just works out of the box. And the immense friction a creator will willingly endure behind the scenes to make sure the user never sees a single error screen.
So to get into the mind of this developer, we have to start with the problem they were trying to solve, right? So Aang is building a console application.
A command line tool. Yeah.
And the ultimate goal of this app is to take some code and generate perfectly formatted PDF documents. To pull this off, Aang is using a few different tools. They're parsing tokens and mapping them to something called Pandoc's Abstract Syntax Tree, or AST.
AST, yeah.
And this is to eventually generate these PDFs using a newer formatting tool called Typst. But before we get into the crash and burn that Aang experiences, we should probably clarify what an AST actually is, because abstract syntax tree sounds, I don't know, like an intimidating data structure from a sci-fi novel.
It does sound intense, but think of an abstract syntax tree like the pure grammatical skeleton of a document.
Okay, the skeleton.
Yeah. Before you can apply a specific font or a margin size or, a color to a piece of text, the system needs to understand the fundamental structure of what it's even looking at.
So it strips away the visuals?
Exactly. Pandoc is a document converter. It strips away all the visual assumptions and breaks the text down into its purest meaning. It builds a tree where it says, okay, this node here is a top-level heading, this branch is a paragraph, this leaf on the branch is a bolded word.
So Aang's application is basically trying to map raw information onto this structural skeleton, right? And then hand that skeleton over to Typst, so Typst can paint it with the correct visual layout and turn it into a PDF.
That's the goal. That's the handoff.
And that handoff is where everything immediately goes wrong. Right out of the gate, Aang hits a massive structural wall, because Typst comes with the default template, right?
It does, yeah.
It's the template that's supposed to be the magic bullet, the one that handles the visual layout for you so you don't have to think about it. But when Aang tries to use this default template, it completely fails.
Just completely falls apart.
It totally breaks down when it comes to rendering Chinese text and handling some very specific demanding formatting requirements that Aang's project needs. Which makes me wonder, why is modern software still so notoriously bad at defaults when it comes to non-English text?
Oh, it's a huge issue.
It seems like every time a developer steps outside of the Latin alphabet, the tools just crumble. It's like buying a one-size-fits-all hat that actually only fits one highly specific, perfectly spherical head shape.
That's a great way to put it. And what's fascinating here is that the problem with defaults in software is that they're never truly neutral. They are baked with the cultural and linguistic assumptions of the people who originally wrote the foundational code.
Right, because the creators build for what they know.
Exactly. We often think of text rendering as a simple one-to-one translation. You press a key, a character appears on the screen.
Simple enough.
But when you're generating a highly structured printed document like a PDF, Text rendering is no longer just typing it. It's incredibly complex spatial geometry.
Spatial geometry. Wow.
Yeah. When a system is designed with English as the default, which an overwhelming majority of our foundational software is, it makes invisible spatial assumptions. It assumes that words are always separated by empty spaces. It assumes a certain average width and height for letters.
And that line breaks can only happen at those spaces or at hyphens, right?
Precisely.
But logographic languages like Chinese don't play by those geometric rules at all.
Not even slightly.
Yep.
Chinese typography doesn't use empty spaces to separate words in the way English does. The density of the characters is completely different.
Right.
The rules for where you're legally allowed to break a line of text, the required spacing or kerning between specific punctuation marks, it all requires a totally different set of mathematical calculations.
So when Aang tried to feed Chinese text through the default Typst template,
Those English-centric geometric assumptions clashed hard with the reality of Chinese typography. The bounding boxes around the characters start to overlap. The software forces line breaks in the middle of unified concepts.
what a mess.
It is. The margins get confused, and the entire visual layout just falls apart. This harsh spatial reality forces developers like Aang to step entirely outside the provided comfortable tools. The default hat simply will not fit, so they have to weave a custom one from scratch.
So the default template goes straight into the trash, and Aang sits down and writes a fully custom Typst template that actually understands the geometry of Chinese typography. Problem solved, right?
You would think so.
Well, no, because once you build a custom template, you face an entirely new, massive hurdle distribution.
Distribution is always the bottleneck.
Right. How do you actually get this custom template to the user? If we go back to our house analogy, you have this beautiful new piece of custom furniture. You could just leave it on the front lawn and hope the homeowner knows how to carry it inside.
Just drag it in themselves.
Yeah, you could put the tips.tip template file in a folder right next to your application executable. But Aang takes a much more aggressive route. Because those default tools failed so spectacularly, Aang wants to ensure this new custom template never gets lost, never gets accidentally deleted, and is always exactly where it needs to be.
Exactly.
So Aang decides to literally bake the template directly into the application itself.
Yeah, this is the embedded template approach, and it is a fascinating pivot in the architecture of the project. To achieve this, Aang modifies the project's configuration. They add a specific module called file-embed to their package.yaml file.
Okay.
Then they activate a very powerful language extension in Haskell called template Haskell. Finally, they use a function literally called embed file to target their custom tips.tip template.
Wait, hold on. Let me stop you right there because I need to push back on this. Here's
Yeah.
where it gets really interesting. If I'm understanding this correctly, Aang is taking a visual presentation file, a template, and hard-coding it directly into the core logic of the application. Isn't that considered a massive architectural flaw?
Oh, absolutely.
Whatever happened to separation of concerns? The core logic goes in one box, the visual presentation goes in another box. If I want to update the template later, I can't just swap the file out. I have a locked box. This sounds like sloppy hard-coding that's going to create a nightmare down the road.
That is the textbook reaction, and it is entirely justified. In a standard computer science curriculum, separation of concerns is the golden rule. You do not mix your data models with your visual views.
Right. Never.
But if we connect this to the bigger picture, we have to distinguish between sloppy hard-coding and what template Haskell is actually doing here. Sloppy hard-coding is when a developer literally types the raw text of a layout template directly into the middle of their logic functions.
Which is unreadable.
Yes, it creates a giant wall of unreadable text sitting in the middle of perfectly clean code. It makes the application impossible to maintain. But Aang is using metaprogramming.
Okay, metaprogramming. How does that fix the locked box problem?
Well, normally a program looks for its templates at runtime, meaning after the user double-clicks the app and it starts running, the app reaches out to the hard drive, searches for a folder, looks for a file called tips.tip, and tries to read it.
And if the user accidentally moved that folder, the app panics and crashes.
Exactly. What template Haskell does is shift that entire process to compile time. It executes code while the application is being built by the developer.
So it's grabbing the file before the app is even finished being created.
Precisely. To use a different analogy, think about packing a lunch.
Okay, I'm with you.
The standard way of distributing software is like packing a lunchbox with a recipe card and a bunch of raw ingredients, separate files in a folder. The user opens the lunchbox, reads the recipe, and has to assemble the sandwich themselves.
And if they lose the recipe card, they go hungry.
Yes. Template Haskell is like putting a fully baked hot lasagna directly into the lunchbox. During the compilation process, the Haskell compiler pauses, reaches out to Aang's hard drive, reads the typst.tip file, translates its contents into a raw byte string, and fuses those bytes directly into the application's memory space.
Ah, I see. So on Aang's computer, during development, the template is still a completely separate file.
Yes. Yeah.
Aang can open it, edit it, treat it like a normal file. The fusion only happens at the very end when the app is packaged up for the user.
The developer gets the benefit of working with clean, separate files, but the end user gets a single, unbreakable binary package. The user doesn't have to cook, they just eat. It is a highly intentional packaging strategy designed to eliminate a specific point of failure.
Okay, that makes sense. It's an intentional choice to force a frictionless experience. So Aang goes to these extreme lengths, literally fusing files together at compile time just to guarantee the user's layout won't fail. Does that same move fast and force it to work mentality bleed into the rest of the code? Because later in the blog post, Aang is surprisingly blunt about how they're handling the internal logic.
Very blunt.
Yeah. If you're looking at production-level code, you might expect to see layers upon layers of careful safety checks and error validation. But Aang essentially writes, I am skipping deep validation right now. I just want a working prototype. They are actively choosing speed over absolute perfection.
Which, frankly, is often the exact right call to make when you're navigating new territory or wrestling with a tricky integration like Pandoc and Typst. You have to get the engine turning over before you start polishing the chrome.
Right. You need to know if the core concept even works.
Exactly.
And to get that prototype working quickly, Aang shares this really fascinating Haskell shortcut for handling errors. Usually in programming, when you check if a process worked or failed, you have to write these bulky, multi-line case statements.
Oh, they take up so much space.
Yeah, like, if the template loads successfully, do this specific thing. If the template fails to load, trigger this specific warning. It takes up a lot of visual space. But Aang bypasses all that bulk by using a built-in function called either. The code snippet they share in the post is literally one line.
One line. It's so clean.
Just let template equals either error id template either. And the mechanics of this are brilliant. So what does this all mean? Think of this either function like a completely ruthless bouncer at a very exclusive nightclub.
The bouncer analogy works perfectly for how Haskell handles data types.
So you walk up to the door of the club, the either function is the bouncer, and he has a clipboard with two possible outcomes, left and right. In Haskell, by convention, the left side of the clipboard is strictly for failures and the right side is for successes.
Standard functional programming.
Right. So Aang's code is basically evaluating what happened when it tried to process the template. If you're on the guest list, meaning the code succeeded, you have your template, and you end up on the right side of the clipboard. The bouncer uses something called the id function.
Yeah, the identity function.
The bouncer just waves you through, untouched, you go right into the club. But if you're not on the list, if there was a formatting error or a processing failure, and you end up on the left side of the clipboard, the bouncer uses the error function.
And it is not polite.
No. This bouncer doesn't gently ask you to leave. The error function immediately kicks you out of the club, shuts down the entire city block, and terminates the program on the spot.
It's brutal, but highly effective. The either function requires 3 distinct arguments to work. What to do if the process fails, what to do if the process succeeds, and the actual value you're evaluating.
Okay.
By passing the error function as the very first argument, Aang is explicitly telling the program, if this template compilation hits a snag, do not try to recover, do not try to use a fallback, crash the application immediately, and print the error message.
Wow. No graceful exit, just pulling the plug entirely.
Right, because for a prototype, you want it to fail loudly so you can fix it immediately.
Makes total sense.
But the truly elegant part of that single line of code is the second argument. Aang actually notes in the post that they covered the id function way back in part 31 of their blog series.
Part 31.
Yeah, they've been at this a while. So id stands for the identity function. From a mathematical standpoint, it is a function that literally does nothing but return exactly what you handed it.
Which sounds completely useless. I mean, why would you need a function that just hands you back what you already have?
It sounds useless until you understand the strict rules of functional programming languages like Haskell. The compiler is notoriously rigid. The either function strictly demands that you provide a function to handle the success scenario.
So you can't just leave it blank.
You cannot. You can't just say do nothing. The compiler will throw an error and refuse to build the app. Ang uses the id function as a brilliant compiler loophole.
Oh, clever.
It's a way to hand the compiler a technically valid function that fulfills the strict requirement without actually altering the data. Ang is effectively saying to the compiler, look, I am giving you a function like you asked, but if the process succeeds, just give me my template back completely unaltered.
That is so smart.
It really is. It reduces what could be 6 or 7 lines of complex branching logic into a single, incredibly concise line of code. It satisfies the strict rules of the language while maintaining maximum pragmatism.
It's a masterclass in knowing the rules so well that you know exactly how to bypass them. But, as we know, every technical shortcut, every pragmatic choice, it has a tangible cost.
Always. There are no free lunches.
Exactly. You do not get something for nothing in software development. And for Ang, the cost of embedding that template into the binary, pouring that concrete furniture we talked about earlier, is paid in pure, unadulterated development friction.
Friction is the defining characteristic of this approach. Because Ang chose to use template Haskell to fuse the template into the application at compile time, they created a massive bottleneck for their own workflow.
Because if they want to change a single thing, they are trapped, right?
Yeah.
Let's say Ang is looking at the generated PDF and realizes the font size for the Chinese characters is exactly 1 pixel too small. In a normal setup where the template is a separate file read at runtime, Ang would just open typst.tip, change 12 to a 13, hit save, and run the app again to see the result. It takes, what, 2 seconds?
Not even 2 seconds.
But because the template is baked directly into the code, Ang can't do that. They have to recompile the entire application from scratch just to see that 1 pixel layout tweak.
It's brutal.
The compiler has to tear everything down, reach out to the hard drive, read the template, convert it to bytes, fuse it into the binary, and rebuild the executable every single time. And that adds incredibly frustrating wait times to the development loop.
And if you've ever done UI or layout design, you know that it is a process of constant microscopic adjustments. You're tweaking margins, adjusting kerning, playing with line heights.
Over and over.
Yeah. Having to wait even 10 or 15 seconds for a full recompile between every single micro adjustment is agonizing. It completely destroys a developer's flow state.
But Ang does find a workaround to preserve their sanity, though, right?
They do, yeah.
During the development phase, instead of using the heavy Haskell application to generate the PDF every time, Ang takes the intermediate Typst output, the raw formatting data, and compiles it manually using the Typst command line interface.
Dropping right into the terminal.
Yeah, they run the CLI tool independently. That lets them test the visual layout changes rapidly without forcing the Haskell compiler to rebuild the whole app. But, I mean, it's an extra step. It is a manual hoop to jump through.
Definitely.
So, looking at the full picture here, is the convenience of giving the end user a single magic binary file really worth the absolute headache of the developer having to jump through terminal hoops and endure all this friction?
This raises an important question, and honestly, it's the core dilemma of modern software distribution. Ang explicitly states in the blog post that they ultimately chose this embedded path because they simply couldn't figure out a clean, reliable way to distribute a separate template file alongside the console application.
Just practically speaking.
Yeah. Think about the physical reality of how an average user downloads a tool from the internet. If you give them an executable file and a separate folder containing the necessary templates, what inevitably happens?
I lose the folder.
Exactly. They drag the executable file to their desktop because they want it easily accessible, but they leave the templates sitting in their messy downloads folder. They double-click the app searches for the template folder that is no longer sitting next to it, and it instantly crashes.
The user effectively breaks the house before they even walk through the front door.
Exactly. By taking on that extreme development friction, by enduring the slow compile times and building those manual CLI workarounds, Ang is actively absorbing the complexity of the system so the user doesn't have to.
That's a great way to put it.
Ang writes that keeping everything compiled into a single binary is the most robust way to ensure the app just works out of the box. That is a profoundly user-first mentality. The developer takes on the headache so the user gets to experience magic. It's a deliberate trade-off.
They're sacrificing their own time.
Yeah, sacrificing their own workflow efficiency for the sake of an uncorruptible user experience.
That is a really powerful way to frame it, absorbing the complexity. And that really brings us full circle on today's deep dive. We started this journey looking at a highly specific, very frustrating formatting problem, the geometric nightmare of rendering logographic Chinese text through a default English-centric layout template.
Yep, the default hat didn't fit.
But by tracing Ang's steps through the Haskell code, we ended up dissecting a developer's very conscious philosophical choice. We saw them prioritize a seamless, single-binary user experience over their own convenience.
Which is rare, honestly.
It is. We saw the mechanics of how they wielded powerful tools like template Haskell to fuse files together at compile time, and we saw how they acted as the ruthless bouncer, using the either function to satisfy the compiler while keeping the prototype moving fast.
It is a brilliant study in balancing the ideal structure of computer science against the messy, unpredictable reality of how humans actually interact with files on their computers.
It absolutely is. But as we wrap up, I want to leave you, our listener, with a new angle to ponder, something that builds on this entire philosophy of absorbing complexity.
Oh, here we go.
If developers increasingly move toward this model, if the standard becomes compiling all assets, all layouts, and all templates into single, impenetrable binary files just to ensure things work out of the box, are we slowly losing the old school, open nature of software?
That's a deep question.
Think about the implications. Because Ang's custom template is forever baked into that binary, an end user can never simply open a folder, find the tips.tip file, and tweak the layout themselves.
They're completely locked out.
If they want the font to be a little bigger, they can't change it. They are entirely locked out of the presentation layer. Are we trading our ability to tinker, to learn by modifying the tools we use every day, just for the comfort of pure convenience? We have poured the furniture into the concrete foundation so the house is perfectly robust and will never fall down. But now, wait, I shouldn't say, but now, I mean, the reality is the homeowner can never rearrange the living room.
It is the ultimate double-edged sword of a single binary approach.
Yeah.
You get stability, but you sacrifice transparency.
It really is. Something to chew on the next time you download an app, and it works perfectly with zero setup. Thank you so much for joining us for this deep dive. Remember, the world of technology is vast and learning is an ongoing journey. Keep asking questions, keep pulling on those threads, and we will be right here with you next time to unpack whatever you find. Take care.